You done, Thameem?
No, sir, I'm still.
Yes, still doing now.
Yes,
But
sir.
are you getting this one?
I think I have an idea of it, but I'm not sure if it's going to be correct.
Not sure. Why not sure? You check it. If you are not able to do it, I'm going to help you. So what is given to you in this question? What is this given? It is Henry constant, KH.
Yes.
1.67 into 10 to the power 8 pascals. Okay. Calculate the quantity of CO2 in 500 ml of water when packed under the 180. So pressure is given to you, that is 2.5. So 1 pascal is equals to 1 pascal is equals to 10 to the power 5.
Yes.
1 atm. 1 atm is equals to approximately 1.0 into 10 to the power 5 Pascal. Okay. So it will become 10 to the power 5, 2.5. Because if it is you are having this one in Pascal, so it is in atm. So you have to convert it into Pascals. Got it?
Yes.
And what is it asking? Calculate the quantity of CO2. Soda in 500 ml of soda. So 500 ml of soda is given to you. What is this?
5.
500 ml of soda.
Yes, sir.
What does this means? Hmm?
We have to find its.
So water when gases are added to water, okay, you need to first calculate the mole fraction of soda, CO2. Okay, mole fraction of CO2 you have to calculate. For this, you have number of moles of CO2, x CO2 will be equals to number of moles of CO2.
Yes.
Okay, and CO2, number of moles of CO2, divided by number of moles of, we have number of moles of CO2 plus number of moles of water, but we will take here water only because it is in very less quantity. So we will neglect the number of moles of CO2 here in the denominator. Okay, got it? It will be
Yes.
x CO2 will be equals to n CO2 upon n H2O. Okay, and how will you get the number of moles of CO2? So it is asking for WB. So it is WB of CO2 upon molecular mass of CO2 into, we will have number of moles of this one. So that is given 500 ml. So you know the density of water is approximately equals to 500 ml water, because density is almost equals to 1. So 500 ml of water will be equals to 500 gram. Okay. So we'll say that here will be WA upon MB. Got it? Are you getting this one? How does this formula become? WB upon MB divided by WA upon MB. How it is? Sorry, this will be MB. So let me explain you that you will going to have number of moles of CO2 will be, number of moles means given mass of CO2 upon molecular mass of CO2 divided by given mass of H2O upon molecular mass of H2O. If I'm saying H2O is A, and CO2 is B. So I can write it like this way: WB upon MB divided by WA upon MA. Okay, this one for this value and this one for this value. So what you can write here is, you will write WB upon MB. This is divided, when this will goes up, so it will become into WAMA upon WB. Okay, got it this one?
Yes.
So write down the
Yes, sir.
value. You need to calculate this value. You know this value. This is 44 for molecular mass of CO2 is 44. Ma is molecular mass of water is 18. And this value is how much? WB given mass of is 500 gram. Calculate it. For that, you have to find out the value of X. And how will you find out the value of X? Mole fraction of X. So you know that P is equals to KHX. So P upon H, KH is equals to X. So first find out the value of X and then equate it with this one. Please do it.
Okay, sir. So it's 0.40.
Okay, done, Thameem?
Yes,
Done?
sir, it's 409. 0.40.
0.40 grams. Okay. Try the one more question, please. Just a minute. Try this question, please.
Okay.
Are you doing?
Yes, sir. So it's 33.6%.
Done. So
Yes,
how much
sir.
it is? How much it is?
33.6.
33.6. So
Yes,
how
sir.
did you solve this question?
So first, the total mass distribution and
I gave
after
you the direct formula for this one. You remember?
I didn't use a direct.
Hmm?
I did not use a direct.
You don't use the direct formula. Okay. Then you
I
will
didn't.
use 300 into 75 means 25. Okay. So you get 33%. And previously we did this question. Was it the same? Should I
Yes,
solve it?
sir.
Okay. So let's move towards the next chapter that we were doing. That was we were doing the. I sent you the homework. Did you get that homework for IUPAC naming?
I did not. So I don't.
Why didn't you do? You are not doing the homework on time.
Yes, sir.
Okay. So let's start moving further. Okay. We're doing hello alkanes and hello rings. Okay.
Yes, sir.
And in the previous class, we were discussing the IUPAC naming, okay, of the compounds. And we were discussing the isomers. Okay. Here we have some questions. Try to unbond this compound and try to write the name, at least write the name of anyone. At least tell me that how many carbons are present in the single chain here. In this question, how many carbons are present? And what should be the name of this compound? बताइए.
What's it?
What is the number of compound here? What is the number of carbon here? How many carbons are there? The first carbon is present here, second carbon
Yes,
is
sir.
present here, third carbon is present here.
3.
Okay, so we'll take there C and one C here, one C here. There are 3 carbon. With the second carbon,
Yes.
we have one CH3 group attached. And there is a double bond between, and there is a Br group attached with this one. Other carbons are attached with hydrogen, so we can attach the hydrogen. There are 3 bonds, 3 and 4. All bonds are bonded. 2 are 1, 3. 2 and 1, 3 and 1, 4. Got it? What is the name of this compound? Numbering should be done from this side or this side?
So it should be, I think it's the same, right? Because,
From here we have to do. The double bond will be given first preference, okay?
yes.
So first we will write the, what we write? We write prefix first, prefix, like chloro, bromo, iodo, okay, fluoro, yeah, group of chain like CH3, CH2, okay, C2H5, okay. So this type of chain or a branch is written in prefix. Then we have root word. Root word means indicate the number of carbon. Then we have saturation indicator. Which is like double bond, single bond between carbon carbon is in, double bond between carbon carbon atom is in, triple bond between carbon carbon atom is YN. Okay, and then we have last is suffix. Suffix we'll have in the functional group we're going to discuss. So if I'm talking about this one, so what is this? First tell me first. What is the name? First you have to write the name prefix. Is there any prefix present?
No, no.
On the third carbon we have bromo.
Yes, sir,
Bromo.
bromo.
And on the second carbon we have methyl. So should I write the name of methyl first or a bromo first?
With that,
Methyl first or the bromo first? If there is more than one prefix present, note it down. If there is more than one prefix is present, if there is more than one prefix is present, then we write their name in alphabetical order. Then we write their name in alphabetical order. Got it? So if we have bromo, another we have uh, methyl. So bromo count first. So we'll write it whether its position is 3. Let it be. But we'll write the bromo name first. Okay. So that will be 3 bromo. And then 2 methyl. The prefix is done. Okay. Then after it is continuing here. Okay. I'm just writing that because I don't have a space, but it is we have to write it here. Okay. Then we have root. The prefix is done. How many root? 3 carbon. For 3 carbon, how much? What is the root? What is the root word for 3 carbon? Tell me fast. Prop. So we'll write prop. Then saturation indicator. Is there double bond anywhere?
yes, sir.
Where?
But
The
we
first
don't know.
carbon. We'll not write it. If it is first and second, it is in between first and second, then we will consider it at first. Okay. The lower number will be good. So we'll have prop. If it is on the first carbon, we don't mention its position. If it is here, if it is suppose here, then we'll write 2 in. Okay. But it is on the first carbon, we don't write its position. Then we'll write prop in. Okay. 3 bromo, 2 methyl propene. Okay.
Yes, sir.
Okay. Just try once more. Just try the names of this one, please. Please try to write the name of these
Okay.
compounds. Okay. Done. I mean,
No, sir, I'm doing
how many carbon are there in the main chain? First tell me.
it. Three, sir.
3. Check it. 1, 2, 3, 4.
Four,
There are
four,
4
sir.
carbon.
Yes, sir.
Right. And double bond is on the second carbon.
Yes, sir.
Done.
Almost done. Sir. 5 promo 135 pro, beauty, beauty
5 bromo. This one, 1, 2, 3, 4. Yes, 5 bromo. Next. Bute to in.
4.
5 bromo, bute to in.
Yes, sir.
Actually, it is correct. Let's move further.
Okay.
Try to the compound can be written and their name can be written like this way. Okay, means if their name are written, will you be able to draw the structures of the compound? If their IUPAC name is mentioned, like for example, like this way, like try to draw this one and this one.
Okay.
Try to write the first this name. Try to write this name first.
Okay.
Done.
No, sir.
So what's the formula for this one? You have done this one only, first one.
Sir, actually, I'm doing the second one. Yes.
You're doing the same. Okay. So 1-chloro-4-ethyl cyclohexane. The main is cyclohexane. So first you have to draw the cyclohexane. This is the cyclohexane. Okay. And number this one. This is 1, 2, 3, 4, 5, 6. Okay. So at the first position, you have 1-chloro. So write the chloro here, group. And then 4-ethyl. At the fourth position, you have ethyl. Ethyl means C2H5. Ethyl group, you know, na? Ethyl group is C2H5. Okay. The alkyl group is, the formula for the alkyl group is CnH2n plus 1. So if it is 2 carbon, then it will be 2 into 2 plus 1. That will be C2H2 to the 4 plus 1, 5. Okay. This is for the ethyl group. Got it?
Yes,
What,
sir.
what is the formula for the propyl group? Propyl. What is the formula for propyl group?
Uh,
Propyl.
it's 3 carbons with
Prop means 3. So 3 carbon, then double this one and then add 1. C3H7. This is propyl.
yes, sir.
Butyl,
There's a 4 carbon.
C4H. H how much? Hmm? Double this one and add one. C4, 4 to the 8 and 1 9. C5H. How many H for pentyl?
Um,
Are you doing something else? Are you
no,
concentrating
sir.
here?
Yes, sir.
So if it is 3, I'm just doubling this number of carbon and adding 1. So 3 to the 6 and 1 added here 7. 4 to the 8 and 1 added 9. And
So,
5 to the 10, 1 added 11. This is pentyl, okay?
yes, sir.
Understood?
Yes, sir.
So if I'm saying that in this one, this is done. Now ethyl, you understood, eth means 2 carbon. Prop means, okay, 3 carbon. But means 4 carbon. So butyl is going to have C4H9, okay? Ethyl is going to have C2, double of 2 is 4 and then 1, C2H5, okay? Got it?
Yes, sir.
What is the name for this chloromethyl pentane? 2-chloromethyl pentane. 2-chloromethyl pentane.
What, sir? I didn't get you. What is that?
2-chloromethyl pentane.
Yes, sir.
So pentane is it a straight chain or long chain? Or some other?
It's a straight, sir.
Straight chain. Pentane, simple chain. So 5 carbon. Okay. And at the 2 position we have chloro, and at the 3 position we have methyl. And you can have the number of hydrogen here. If it is bonded with 3, it will be H. If it is bonded with 3, it will be going to have H only. Got it?
Yes, sir.
Next is 4 tertiary butyl. First of all, I'm going to explain you what is tertiary butyl. Tertiary butyl. Butyl means having 4 carbon, and tertiary means in which carbon is, it will be having the formula C4H9. Butyl means C4H9. Okay. But if I'm saying tertiary, tertiary means the carbon is attached with 4 other carbon atoms. So this one is C, 1C here, 1C here, and 1C here. This is tertiary butyl. It is bonded. Okay, now it will be attached with some other. So this will be 1, 2, 3, 4. 4 carbon and 3, 3, 3, 9. This is C4H9. This is known as tertiary butyl. You know that this carbon has made 3 single bonds, but not here. So this will attach with the chain. If this is going to attach with someone, so this will be attached. Okay. So this is known as tertiary butyl. What is the name of this one? Is tertiary. Okay, or we can write tertiary butyl. Okay, you understood? Tertiary butyl. So this tertiary butyl group, is attached at the with the at the 4th position, 4 tertiary butyl and 3 iodohaptane. Haptane means 7 carbon. So there will be 7 carbon, 1, 2, 3, 4, 5, 6, 7. Okay. And at the 4th position, we have tertiary butyl. So we'll write here tertiary butyl like this way. And at the 3rd position, we have iodo. Iodo at the 3rd position. So if I'm numbering it from here, so it will be the 3rd position. If I'm numbering from here, 1, 2, 3, it would be the 3rd position. So this will be iodo means iodine is attached. Okay.
Yes, sir.
Got it? So this is 1, 2, 3, 4. So 4 tertiary butyl, 3 iodopentane. Okay. Got it?
Yes, sir.
And there will be CH3, CH2. This carbon has made 3 bonds. So this will be only H. This carbon has made 3 bonds. There will be only H. Then it will be CH2, CH2, CH3. Got it? Got it? Draw this one. 4 tertiary butyl haptane, 3 iodohaptane. 4 tertiary butyl, 3 iodohaptane. Done? Noted?
Once. Done.
Okay. Try the next one. Just a minute. Try this one. Try the fourth one. Write the name of four tertiary butyl iodohaptene. We have done this one. 1,2-dibromo butene. 1,4-dibromo butene. Write the name of this one. Fourth one. Try to draw the structure of this one. Sorry.
Okay.
You done?
Yeah. Yes, sir.
Okay. 1,4-dibromo butene. 1,4-dibromo butene. So how many carbon are there in the main chain? Tell me.
So 4 carbon.
Okay. And 1,4. So 1 and 4, we have dibromo. So one bromo is here, one bromo is here. Okay. So we are just
Yes,
assuming this as one position. So this will be the fourth position. So 1,4-dibromo butene. So at the two carbon, there is double bond. Ene. Okay.
yes,
Got it? Try the
yes,
name
sir.
of this. Try the name of this fourth one. Fifth one.
Okay.
1-bromo, 4 secondary butyl. What does the word secondary butyl means? Like it was tertiary butyl, secondary butyl means? Let me explain you what is primary butyl. Primary butyl is this simple. CH3, CH2, CH2, CH2. This is primary butyl. Okay, 4 carbon. Secondary butyl is CH3, CH2. Okay. Okay, CH2. And then we have CH. Okay. Sorry, CH2 here. And then it will be this carbon is attached with one more carbon. Okay. So this is secondary butyl. And the main carbon is attached with this. Okay, got it? No, this is tertiary butyl. This is tertiary. Secondary butyl is this one. If suppose this chain is going to attach with the main chain, main branch. Okay. So we will have it, we will going to have CH3 group here. 1, 2, 3, 4. Okay. So actually second carbon is going to attach with this one. Okay. Got it?
Yes,
And
sir.
there will be CH only, CH. Because it has one bond, Three bond and four. Okay. So this is secondary butyl. What is this? This is secondary butyl. Butyl. This is primary butyl. Primary butyl or only butyl? And what is tertiary butyl? CH3, C. Got it? This is tertiary butyl. Got it?
Yes.
Next. So what is saying? What is in the question? It is saying secondary butyl. At the first is bromo. Then we have secondary butyl. Then at second position we have methyl and then benzene. Benzene. Secondary butyl. Benzene. Okay. So it is actually the main is benzene. Benzene ring. Let me draw it here. Okay. Let me draw it here.
Yes.
So it is benzene. Okay. And if I start numbering this one, 1, 2, 3, 4, 5, 6. Okay. So this is the 6th position, this is the 5th position, this is 4th position, this is 3, this is 2, and this is 1. Okay. I'm just writing it away. Far away. And second position we have methyl groups. Like second position we have right methyl CH3. You know methyl group is CH3. Got it?
Yes, sir. Yes, sir.
And in this one, 1 bromo, 4 secondary butyl. And in the first position we have bromo. So 1, we have bromo. And in the fourth position we have secondary butyl. So how will I attach secondary butyl? Secondary butyl. So secondary butyl, 1 carbon is attached with the main chain, CH, and this is also attached with CH3. Okay. And then this carbon is attached with CH3, or we can write it. Okay. We can make the chain here also.
Yes.
This is the 4 carbon required, CH2, and then we have CH3 here. Okay. So if this carbon is attached with here, like this way, if this main carbon CH2, then CH3, sorry, CH2, then CH2, and then CH3, like this way. Okay, directly to this is known as primary butyl, or we will write only butyl group, not secondary. But if the second carbon is attached, then it will be a secondary butyl. Okay, got it?
Yes.
Got it? Okay.
Yes.
So note it down and draw this structure, please. And write the name of it also. You done?
Almost. Done.
Okay, let's move to the further part of this chapter. Now, if you are having an issue with the secondary butyl and tertiary butyl, we will discuss it. Okay,
Okay, sir.
got it? Because it something needs a little bit time for its okay. So brain need to means if you are just keeping it in your brain for forever, then you have to give the time to the brain. Okay,
Yes.
like you are becoming good in the numerical problem of the first chapter solution. Similarly, you will be able to do this one. Okay, now the next topic is preparation of alkanes. How can we prepare the alkanes? What a topic, preparation of alkane. Preparation of alkane. Preparation of alkane. So if I talk about this one, that you know that there is an hydroxyl group of alcohol, okay? And this
Yes.
hydroxyl group can be easily replaced by the halogen group on reaction with concentrated halogen acids or phosphorus halides, okay? Or thionyl chlorides. Because simply I'm just going to say here that if we, how can we prepare an alkane? How can we prepare an alkane? So if we can prepare it with the help of alcohol also, we can prepare it with the different things also, okay? So how we can prepare an alkane? There can be so many other groups or so many types of reactions that is being used for the preparation of alkane. The first type of reaction is with the, if alcohols are going to react with halogens, means they convert it into halogens. Okay, first of all, let me explain you that halogens plays a very important role. For example, if I'm having these reactions, okay, from the NCRT, and this is alcohol, okay, this is an alcohol. Alcohol, you know, functional group of alcohol, you know, aldehyde alcohol.
Yes.
OH is a functional group which is known as alcohol. So if any compound is having any hydrocarbon is ended with having group OH at the end, like CH3OH, it is one carbon alcohol. If it is C2H5OH, it is two carbon alcohol. Okay, got it? Like similarly, we have another functional group like CHO. This is known as aldehyde. Aldehyde, CHO. Okay. Then after aldehyde, we have carboxylic acid, COOH. This is carboxylic acid. Carboxylic acid. Okay. Got it? So if I'm talking about the alcohols, that you can prepare this one with the help of alcohol. So what happens here is that when alcohols react with acids, generally with acids, alcohols when react with acids, they will give you alkyl halides. Alkyl, they will give you alkyl halides plus halide plus acid. Okay, plus water. Just a minute, there is someone on the door. I'm just coming. Okay, just a minute. Okay.
Okay, sir.
So, Thameem, one thing is that what is alkyl halide if I'm talking about? Alkyl halides plays a very important role in the preparation of most of the compounds. Alkyl halides plays a very important role in the formation of various or numerous compound that you are going to have in this and you are going to studies. And we considered this one that alkyl halides are the activated form of hydrocarbons. Activated form of hydrocarbon. Hydrocarbon. Okay, got it. So first of all, if I need to make something, first I need to make it alkyl halide. Okay, because alkyl halides are reactive and they can easily react. Okay, so in most of the compound that you will going to study, that first of all, when we are just making any compound, we just try to make it an alkyl halides. Okay. Like for example, if I'm having C2H5OH, this is ethanol. This is a 2-carbon alcohol, ethanol. When react with HCl, hydrochloric acid, then this chloride ion will get attached with this one, and these OH and H ions are going to make water. Okay, so we'll simply say here that this C2H5Cl plus H2O plus H2O. This C2H5Cl, this is known as alkyl halide. Why it is alkyl? You know that alkyl group are, these are the alkyl groups. What are the alkyl groups? This is CH3 is an alkyl group. The chain or the branch is known as alkyl group, which is 1 carbon less. Okay. Alkane is alkane. What is the difference between alkane and alkyl? Alkyl. Alkane general formula is CnH2n plus 2. And alkyl general formula is CnH2n plus 1. Okay. There is a 2 and here is 1. Means here is 1 carbon less. For example, I am saying CH4 is methane. Methane. Then CH3 is methyl. Methyl, and it is an alkyl group. Got it? If I'm saying C2H6 is ethane, then we'll say that C2H5 is ethyl. It is an alkyl group. Okay, got it? Understood? Yes or no?
Yes, sir.
So alcohols when
Yes.
react with acid, they will give you alkyl halides. Okay, and these alkyl halides, once they are formed, okay. So we are just studying that how to prepare haloalkane. Halo means halogen, and alkanes, you know, alkane. So this is an haloalkanes or alkyl halides. Alkyl halides, or haloalkane. Haloalkane are the same thing. Alkane are the same thing. Okay, got it? Alkyl halides and haloalkanes are the same thing. Got it? So when it is going to react,
Yes.
it will give you, okay, 1 degree alcohol and alkyl halides, and this is done in the presence of zinc chloride. Got it? Zinc chloride.
Yes, sir.
Okay. If we are having, if we need to add, let's suppose if I'm going to add bromine here, so we'll take HBr. Okay, we'll not take ZnCl2. The common name, the common ion should be taken. If it is Cl here, and we want to set Cl. Okay, so accordingly we have to use. Okay, not every acid is going to give you. For example, if you need ROH, okay, and you are just you need to add Br group. We will add HBr here. Okay, at that time you are not going to use ZnCl2. Okay, they will use some other compound which is going to have Br. Okay, so accordingly you have to use. You understood?
Yes, sir.
The second is when alcohols preparation, we are just using the alcohols here. Okay, with the help of alcohol we can prepare it. So first is alcohols when react with sodium bromide in the presence of H2SO4. For example, we need to add bromine group here. We will take NaBr, sodium bromide. Okay, sodium bromide. And here we will take H2SO4 in this presence. Got it? The sulfuric acid will be, so we can take here that if we are just going to react alcohol with H2SO4, it is an acid, but here it should be in place of the like here word ZnCl2, it should be NaBr. So it will gives you RBr plus water plus NaHSO4. Okay, you have to memorize these reactions. Got it?
Yes.
Got it? The next one
Yes,
is ROH when react with PX3. PX3 means it is an halogen. It can be a halogen. X means indicate fluorine, not the fluorine except the fluorine and bromine. Okay, so this will be a fluorine, bromine, but fluorine should not be there because PX is not available every time. Okay, because fluorine reaction with fluorine is so exothermic, so it is not available every time. Okay, just give me a minute.
Okay, sir.
Yes. Okay. So if I'm talking about this one, just you have to note it down that, for example, if it is ROH, Okay, this is an alcohol. R means indicate alkyl group, OH group indicated with alcohol. Okay, but you need to keep in mind what is R. Let me explain you. R can be any chain. R can be any chain. Like for example, CH3, CH2, CH2, CH3. What is it? It is 1, 2, 3, 4, 4 carbon butane. And if I remove one hydrogen from it, okay, then one valency of the carbon will get free. Are you getting my point? Let's suppose there were 3 hydrogen, one here, one here, one here, the last one. If I remove one hydrogen from here, now it is an alkyl group. Now it has become alkyl group. It is an alkyl group and its name is butyl. And you can attach anything, any group to it. Like if you attach it alcohol, OH group, so it will become alcohol. If you instead of this alcohol, if you attach chlorine group, then it will become haloalkane or alkyl halide. This is an alkyl group and this is halide, halogen. Got it? If you add CHO group to it, this will become aldehyde. If you add COOH group to it, COOH group to it, it will become carboxylic acid. So you have to think it in very simple manner that we need a chain. We need one hydrogen less so that we can attach another group to it. Are you getting my point?
Yes.
Are you getting my point? Okay. Now, if I'm talking about this ROH, okay, this ROH when react with PX3, it will give you 3RX, okay, 3 times of RX and H3PO4. Let me explain to you. Let, for example, if you are having ROH, okay, ROH, alkyl, ROH, alcohol, any alcohol you can take, okay, and if it is reacting with phosphorus, okay, and here if it is trichloride, if it is like PCl3, okay, I'm taking chlorine here, Cl instead of X is an halogen, X indicate chlorine, bromine, okay, it is an halogen, so I'm just taking Cl, PCl3, okay, then what happens, what is going to happen here is that this R, there will be, means every chlorine atom will be removed. We have 3 chloride ion here. We have 3 chloride ion. Let this is ROH, 3 ROH group here. Okay. So this, in place of this, 1 chlorine will get here. Okay. In place of this hydrogen, 1 chlorine will comes. And in place of this OH group, 1 chlorine will come. Okay. 1 Cl group will come. So how many RCl group we are going to have? RCl will we have 3. Okay. So we need 3 this one to balance this. Got it? Because they are 3
Yes.
chloride ion, so we need alkyl 3 alcohol here. Okay. Plus we have now how many? We have 1 phosphorus here and 3 hydrogen and 3 oxygen. So we will have H3PO3. This is known as phosphorus acid. Phosphorus acid. Okay. Understood? So 3H and 3O. 3H and 3O. Got it? And
Yes.
1P is going to form phosphorus acid. So this is when we are reacting it with PCl3. Now, the next one is if we are having PCl5, it is important. If we are having PCl5 instead of PX3, for example, if it is C3, then we require 3 alcohol, 3 times alcohol, and we will get 3 times of alkyl halides. But if you are having PCl5, then only 1 alcohol will be reacting and will be given to this one. This time it is not going to give you the 5. For example, if I'm having ROH, when it is reacting with PCl5, okay, then what it will going to give you? It will take only RCl, only 1 chlorine, okay, and 4 chlorines. Out of this 4 chlorines, okay, 1 chlorine will come with to form HCl, and 3 chlorine will be with POCl3, okay, got it? They will form POCl3, and then you have to memorize this one. POCl3 plus HCl. So 1 hydrogen and 1 chlorine from this one will form HCl, and 1 chlorine from this one will form this one, and now remaining is O and P and 3Cl. So OPOCl3. Got it? So this is going to form.
Yes.
Got it? So what is the benefit of this one? If we have PCl3, then we have more. We need at least this one. So we need 3 alcohol, 3 molecule of alcohol are going to react only with 1 molecule of PCl3. But here, if we have PCl5, then we need 1 molecule of this one will require one this one. In the previous one was requiring 3 alcohol to react. So that reaction was good because in that one molecule of PCl3 is reacting with three molecule of alcohol. But in this one, only one is reacting with this one. Okay, got it? You understood? Here we
Yes,
have
sir.
three alcohols and one this one. So one this PCl3 is able to form, is reacting with three molecule of alcohol to give RCl, 3Cl, RCl. Okay. Now next one is alcohol. Alcohols when added to directly, okay, with in the presence of red phosphorus and X or chlorine gas. Means in the presence of red phosphorus, if we are just going to pass chlorine gas with, okay, like for example, if we are having alcohols and we are passing chlorine gas or bromine gas or chlorine gas, Cl2, Br2, etc. in the presence of red phosphorus, then it will gives you simple RCl. आपको alcohol RCl. Got it? Got it?
Yes, sir. Yes, sir.
And the next one is that this is very important. This is very important, and mostly this is used. This is used. It is important. This is only used the preparation of alcohol at the commercial level. Why? Because in this one, when we are passing alcohol with SOCl2, okay, then RCl is going to form, and then we're going to have SO2 and chlorine SCl. And this is also in the form of gas, and this is also in the form of gas. So this will evaporate, okay, and only this will we will find. So this type reaction help us in order to get alcohol in the pure state. Got it?
Yes, sir.
Got it? So this is very important that when alcohol RH is going to react with SOCl2, then it will gives you RCl plus sulfur dioxide plus SCl. And these are in both gaseous state. And because of this, these are in gaseous state, they can easily evaporate, and we will get this one in the beaker. Got it? So in the pure state, we'll going to get the alkyl halide. Otherwise, in this one, we will have this one. In this one, we have H3PO4. Then we have this one. So there is always, okay. So if you are just going to get the pure state, so this will be, this is easy for it. Okay. So please write down all the preparation reactions of alcohol of haloalkane with the help of alcohol.
Okay, sir.
Done?
Uh, yes,
Okay, do it. Take your time. Done?
Yes, done.
Okay. Next is from free radical mechanisms, we can do this one. Okay. What is free radical mechanism? That whenever we are just having an hello LK, okay. Like for example, if I'm having CH4, got it? And if I heat it, if I pass the chlorine gas or any gas through it in the presence of UV rays, in the presence of UV rays, if I'm passing chlorine gas to it in the presence of UV rays, okay, then what is going to happen here is that this is CH4, one hydrogen is bonded with this one. Okay, and this is chlorine, one chlorine atom here. Okay, then free radical mechanism means that the bonded electron, that for example, one electron is bonded here, one electron is bonded here, and they're making a single bond. So the bond will break like this, that this electron will be carried by this chlorine atom and this electron will be carried by this chlorine atom. Similarly, if the bond is going to break with this one, this electron of carbon will be with this carbon, and this electron of this hydrogen will be this with this one. So this is known as free radical mechanism. Okay, understood? Known as free radical mechanism. So if I'm having this one, C H H here, and then when this bonded with when this bond is broken, so one chlorine atom, okay, will come and will make bond with this one, and then plus one hydrogen from this one and one chlorine atom will make bond HCl. Got it?
Yes, sir.
Got it? So when we keep on passing the gas through chlorine gas to it, so it will further react and it will gives you CH, like it is CH3Cl, further react with chlorine gas in the presence of UV rays or sunlight. Okay, it will give you CH3, CH2Cl2. CH2, one more hydrogen will be removed from here, and one more chlorine atom will be added, and then again HCl. Then when keep on passing, it will gives you CH2Cl2. When we are passing it chlorine gas to it, it will gives you CHCl3. One more chlorine atom will be added, one more hydrogen will be added. Okay, and the next one is CH2, CHCl3. When passed more chlorine gas to it, will get CCl4 plus HCl. But the problem of this type of if I ask you what is the problem behind this type of preparation, problem is that we'll going to have all the kinds of alkyl halides. Like we will when we'll get this one, we'll get some amount of this one also, some amount of this kinds of particle also, some amount of this one. Means we'll get chloromethane, dichloromethane, okay, trichloromethane, and tetrachloromethane. So we'll get all of them. This reaction does not mean that step by step it is going to get. All kinds of alkyl halides you will get. CH2, Cl2 will be there in the mixture. CHCl3 will be there in the mixture. CCl4 will be there in the mixture. And this one is also in the mixture. Understood?
Yes, sir.
Understood? So this is the demerit of free
Yes.
radical mechanism, that when we are just preparing the alkyl halide by this method, we'll get all kinds of substance to it. Okay? Got it? Got it?
Yes, sir.
Free radical chlorinations and brominations of alkane give the complex mixtures. It is going to give you the complex mixtures of isomeric mono poly haloalkane, and which is difficult to separate as pure compounds. We can prepare it by free radical mechanism, but we can't. If suppose we need only dichloromethane. This is dichloromethane. Okay, so we can prepare dichloromethane by this one, but this mixture is going to have chloromethane also, trichloromethane also, and tetrachloromethane also. So it is very difficult to separate by this method. Okay, you understood what I'm saying?
Yes.
So please note it down. That is written here. Write this one. Done.
No, sir, last. Done.
Next, if I'm talking about the next one is from alkenes. We can also prepare it from alkenes. It's very simple to prepare it from alkenes. For example, if I pass the HX, means hydrogen chloride or hydrogen bromide to it, okay? So, for example, if I'm talking about this one, let for example, you have CH2 double bond, CH2, this is an alkene, okay? And when you pass it with HX, like HBr, HCl, you pass chlorine gas to alkene. So what it is going to have? It will break this bond. It will break this bond and it will gives you CH2, single bond CH2, and the one valency of this carbon, one valency of this carbon will get free. So with one, we will attach the hydrogen, and with another, we will attach the chlorine. Got it? Got
Yes,
it?
sir.
And this is known as okay, but this is simple because there is the two carbon. But if I'm having CH3, sorry, CH2, or if I'm having CH3, then CH2, then double bond, then CH2. Okay? And here will be CH, only CH. CH, because it is making one bond here and two bonds here, one with the hydrogen. So it is CH. Okay? And if I'm reacting with this SCl, got it? Then it will gives you, now this is a time that when this carbon CH3, CH, single bond, this bond will break and this will have CH2. Okay. Now you know that we have to add HCl. So previously we add the Cl here and H here. We can add the Cl here or H here because they both are having same number of hydrogens. Okay. But
Yes,
in this
sir.
case, if I'm talking about this chlorine, the chlorine will goes to that one valency of this carbon and one valency of this carbon is going to free. So the chlorine will go on that carbon, which is going to have less number of hydrogen. Okay. And the hydrogen will goes to that one, which is going to have more number hydrogen. Okay. The first compound, this will be formed. Another compound is also formed. Both the kind of compound will be formed. In that one, it will be chlorine will be here and H will be here. But this will be the major compound. It means it will be in 90 to 95% this compound is going to form. This is a major compound. This will also form, but this will be in minor. This will be the minor compound. Minor.
Yes.
Minor. Okay. So this is called Markovnikov rule. Markovnikov rule that you have studied in the 11th standard. That according to the Markovnikov rule, okay, when alkane is going to react with the hydrogen HX, okay, like SCl, HBr. So that in that case, the chloride or the halogen group will attach to that portion or that carbon, which is going to have less number of hydrogens. Okay, understood? Less number of
Yes.
hydrogen. But if we have, suppose if we need CH3, CH, okay, double bond and here and CH2, and I am just reacting with HBr in the presence of peroxide, and there will be only HBr will be used, only HBr. Okay, it should be there. So in the presence of peroxide, peroxide means like H2O2. This is peroxide. So in the presence of peroxide, it follow the anti-Markovnikov rule. This follow the anti-Markovnikov rule. Anti-Markovnikov rule. Okay. And what is anti-Markovnikov rule? That this time the halogen group will attach to that carbon, which is going to have more number of hydrogens, like CH3, CH. Okay, this bond will break, and one valency of this carbon, one valency of this carbon will going to be, okay. So this time the Br group will attach to this one, and H will attach to this one, and this will be a major compound.
Yes.
Major compound. Okay. So this is called anti-Markovnikov rule. but it is done in the presence of peroxide, and there should be only HBr, not HCl, not HI. Okay, got
Yes.
it? And if the same, if we don't use the peroxide, like we have CS3, CH2, and we are having HBr this time, but not peroxide, no peroxide ion is present. Then again, CH3, CH, Br will be attached to this one, and we have CS2 and CH will be attached to this one. So this is Marconi co-group. Following Marconi co-group, okay? And if I do this reaction within the presence of peroxide, then bromine will be attached to this one and hydrogen will be attached to this one. Please note it down. Each and everything. When you're done, please let me know.
Okay, sir. Done, sir.
Done.
Yes, sir.
Okay. This is the same thing if we are having I. So I is attached with the major compound means the second with this. This is having less number of hydrocarbons. Sorry, hydrogen. So I is attached with this one. You can check it. Second carbon. And this is the minor which is attaching with this one. Okay. Got it?
Yes, sir.
Got it? Next one is addition of halogens. If you are passing only halogen to this one, then in the presence of CCl4, then we will get vicinal dibromide. Okay. Like for example, if you are having a CH2 double bond, this is an alkene, and we are just passing chlorine gas to it, bromine gas to it, like we are passing. Okay. In the previous one, we are having HBr, we are having HCl, not directly chlorine gas. But this time, if we pass the bromine gas or the chlorine gas to it, directly chlorine gas, then the valency will be detached, and we will have H here, H here, H here, H here, and one valency of this carbon, one valency of this carbon will fit. We'll get bromine here and bromine here. But this is having dibromine. This is not a single. Okay, so, okay. So it's a
Yes.
dibromoethane, dibromo. Understood?
Yes.
Moving to the next part here is, let's we have this question. Here's the question. Identify the possible mono-chloro structure isomer expected to be formed by the free radical mechanism. Free radical mechanism means we have CH3, and there are two CH3, means one CH3 is attached with this CH3, then CH, and this is also CH3. Okay, so this with this CH, the two CH3 group is attached, and then we have CH2, and then we have CH3. Okay, and we are doing free radical mechanism. We are passing chlorine gas to it. Then what type of compound you are going to think that it is going to form?
Uh,
So free radical mechanism means the carbon can be attached with this one. Okay, so one you will get CH3, CH3. Okay, then CH2, and then CH2, sorry, CH3, sorry, CH2 and Cl. CH2 and Cl. Okay, one means one will with this one hydrogen will be attached to this one. Okay, this will become CH2Cl. Okay, in the second case, this hydrogen will be attached and it will form CHCl. The third case, this hydrogen will be attached and it will form CHCCl. Okay, and in this one, this hydrogen may be attached, may be removed. Okay, so this type of compound, 1, 2, 3, and 4, CH2Cl. So this type of compound can be formed. Okay, one by one.
okay,
Means
sir.
what I'm saying here, that it can be the next compound can be CH3, CH2, and then CH3, it is CH3, and now this will become CHCl. One hydrogen will be attached from this one, becomes CHCl. Okay, this is the second compound. This is okay. This is a third compound can be CH3, C, and CH3, and then CH2, then CH3, and here can be the Cl. So one by one, there can be so many compounds that can be formed by this method. Okay, understood?
Yes, sir.
Have you
Yes, sir.
noted this? Have you noted this question?
No, no, sir. I'm not even down.
Okay, note it down. Done?
No, sir.
Yes, Thameem. Why you left?
Uh,
Next is done. Noted.
yes, sir.
Okay. Now moving to the next part is exchange of halogens. This reactions already occurs in the presence of, okay, like for example, if I'm talking about the exchange of halogens, okay, halogens. For example, formation of alkyl fluoride is a very exothermic reaction. Exothermic reaction. Okay, for example, if you passed methane gas with the fluorine, like in the previous one, we were having CH4, we are passing chlorine gas to it. Okay, and it was giving you CH4, CH3, Cl. Okay, okay, but if you pass methane gas with the fluorine, it is very exothermic reaction. It is just like bomb blast. Okay, so we were preparing here. Okay, if we are passing chlorine gas to this one, so it is easily possible. Okay, like in the previous one. But if you want to prepare sodium, if you want to prepare alkyl fluoride with fluorine, so you can't react with, we can't pass fluorine gas to it because it is highly exothermic. Okay, if I'm passing fluorine gas F2 with this one, so if you think that is will form CH3 F and plus HF, so it is highly, very exothermic, very exothermic. Exothermic. So we can't prepare it HF with this way. We can't prepare it with this way. So how we do prepare this one? So first we will take the, like for example, first we take HBr. First we will take H3Cl. We'll prepare this one by this method, okay, or any method. We'll take this one and we'll pass AgF to it, AgF, silver fluoride. Then it will, in the presence of dry acetone, okay. Acetone is ketone, okay, or propanone. So dry in the presence of dry acetone, okay, it will gives you CH3F plus AgCl. AgCl. So means exchange of ion is possible if we are having already HX, like it can be HBr, HCl or HBr. It can be CH3 Br if you are trying it with this one. Okay, in the presence of dry acetone, it will give you CH3F plus AgBr. Okay, so exchange of ion is possible. So why if we can't prepare fluorine with this way, methyl fluoride? Methyl fluoride is not prepared by this way. So for this preparation, we need already an alkyl halide, and then we have to pass it with the metallic fluoride. Okay, metallic fluoride means silver, like it can be silver fluoride, sodium fluoride, it can be. Okay, so note it down this reaction, that note some important point. Alkyl halides are often prepared by the reaction of alkyl chlorides or bromide with this one. Okay, and this reaction is known as Frankenstein reaction. This reaction is known as Frankenstein reaction. Okay, just note it down this one.
Yes.
And then additional synthesis of Frankenstein reaction.
Okay. That's
Done.
yes.
Have you noted these reactions? That SCH3Cl when react with AgF, it will give you in the presence of dry acetone, it will give you this one. Have you noted this reaction?
No, not with land.
Note it down, please. Done?
No, no. Done.
Okay. Now the next topic is preparation of halo arenes. Arenes means simple. Okay, arenes means there will be benzene rings. Okay, so we'll have this one. Uh, Alkyl chlorides or alkyl bromides can be produced, and we have toluene. This is called when we have benzene ring. Okay, and benzene ring when attached with CH3 group, it is called toluene. Toluene. Okay, toluene. So this is toluene. Toluene is passing with X2 means chlorine gas in the presence Fe dark. Fe iron in the dark. Okay, then it will gives you two kinds of uh, group. One is ortho halotoluenes means if it is Cl2, like for example, if I'm having this benzene and if I'm having this CH3 group here, okay, and if I'm passing chlorine gas to it in the presence of Fe in dark, okay, then it will gives you CH3 here, okay, and here it will be Cl plus one is ortho, another will be para. P indicate para, O indicate ortho position, P indicate para position. Okay, it will be CH3 and it will be para will be O here. Okay, got it? And this will be the major compound. This will be the major because of the symmetry. Okay, because you know that this is repelling compound. So this will be the major, and this will be the minor product. Minor, minor. And if I ask you that why on this position, if it is this one is, for example, if I'm making this one and if I'm using that, this is the first position, this is second, this is third, this is fourth. So for this para position is this one. This is the para position. For toluene, this is the para position. So if I ask you that we are having Cl group here and we are going in the next one, we are going Cl group here. Instead of this one, we are having Cl group here. Why not we are getting at this position? Why we are not getting at this position? At meta, this is the meta position. This is known as meta. Why we are not having meta halotoluene? So this we will going to study when we will study the benzene structure, the chemical properties of benzene. So there you will notice that when we uh, have CH3 group and then in that case it's resonating structure. Means resonating structure that we're going to study after two class. Okay, then we will going to know that why it is not coming at the meta position, why it is coming only at the para and ortho position. Okay, why it is not coming on the third position. You understood? Why it is not forming why it is not forming this compound here, why it is not coming Cl here if CH3 is here at the 1, 2, 3, third position. Okay, so we'll learn it in the next class. Okay, got it? Understood? So please note it down. Note this reaction. And iron here is acting as a catalyst. Okay. One thing you have to note it down that fluoro compounds are not prepared by this method because fluoro is very exothermic reactions, and I have explained you that if you pass chlorine gas or fluorine gas to anything like here, if you are passing fluorine gas to directly to methane, alkane, then it will have very exothermic. And similarly, if you pass fluorine gas to this toluene, then it will be also exothermic. So we can't prepare fluorine by this method. Matlab, okay, fluoro compound by this method. So here you have to note it down that ortho and para isomers can easily be separated. And ortho, this is an ortho ortho position, okay, and this one is meta position. So they are can be easily separated by having a difference, large difference due to their melting and boiling points. Okay, this is this is symmetrical. Okay, and so they have difference in their melting and boiling point, and as a result of which they can be easily separated up. Okay, reaction with iodine are reversible. Means if you are reacting with iodine, so this can be reversed also in nature and require the presence of an oxidizing agent HNO3 or HiO4 to oxidize Hi to form. Fluoro compounds are not possible by this method due to high reactivity of fluorine. Okay, got it? So note it down only this line that these ortho and para can be separated out because of having higher difference in their melting points.
Yes.
Done?
Yes.
Got it?
Yes.
Next one is Sandmeyer reactions. This is also important, but there we will need benzonium salt here. Benzene dibenzonium. Okay, let's have a question over here. Note the question, please, and write the product. It only product. So if it is not having any peroxide, so this is simple Markovnikov rule will be followed, and the bromine will be attached to that carbon, which is going to have less number of hydrogens. So this is the double bond here and here. So here we'll have, and this will be like benzene group attached with this, and in this one we have one carbon here, one hydrogen here, and double bond, and then carbon, then hydrogen, then hydrogen. So this carbon is attached with only one hydrogen, and the bond, when bond is going to break, this bond is going to break, one valency of this carbon and one valency of this carbon will be free. So Br will come to this one and H will come to this one. Okay. Understood?
Yes.
Similarly for this one, in which HCl, if it is the first, second, third, fourth, which carbon is going to receive the Cl, chlorine? Which carbon is going to receive chlorine and tell me in the second one?
Uh, so I didn't understand.
You didn't understood this one.
No, no, no.
It's
Like the one which
CH3, CH2, CH, double bond, then CH2. Okay. And we are reacting with HBr without peroxide or HCl. Okay, HCl.
oh,
So we are just going to break this bond. Double bond will be broken. And when double bond will broke, the one valency of this carbon and one valency of this carbon is going to break. The chloride ion will go to that carbon which is going to have less number of hydrogen. So which is going to have less number of hydrogen? This carbon or this carbon? Thameem, you there?
yes, you can hear me.
Yeah, the second carbon will receive the bromine and hydrogen will comes to this one. Okay. But if we have peroxide here, like we have peroxide, then
Uh,
then okay, when this bond is